Alright guys, I hope everybody had an amazing day today. We are going back to the derivatives of trigonometric functions, and we are just going to solve some examples together. So the first one, what we do want to find is we want to find the derivative of the function that is described as f of x is equivalent to x squared sine of x. And to figure out the derivative of this, notice this is multiplication. So we need to use the product rule. So the first thing that we are going to do is we are going to find the derivative of the first term. I just whited out something here. So 2x. And then we are going to multiply it by this expression that is not changed, so sine of x. And then we are going to add the derivative of the second term, and the derivative of sine is equivalent to cosine. And we will multiply it by x squared, the first term that is not changed. If I want to write this a little bit nicer, I probably should say that x squared should be in front, so I would have x squared cosine of x. And then here, well, this can stay. We can say 2x sine of x. And we are done. So we are just applying the rules from yesterday, and we can see how the trigonometric function can be a part of our derivative finding. All right, let's take a look at the second one. And the second one, we have a quotient. So we have a cosine of x over x. So if I want to find the derivative of this, I am going to find the derivative of the first one, and the derivative of the first one is negative sine. Then I am going to multiply it by the term that is on the bottom. Then I will remember about negative sine. Derivative of this is 1, and then cosine of x doesn't change. And I am going to divide it by the by what's on the bottom of the fraction, and I'm going to square it. Let's see if this can be anyhow cleaned up. It's just a proper way, or more proper way, to put the x in front. Notice if I was going to put the parentheses, that would be here. The second x is not a part of the trigonometric function. Minus cosine of x, I don't need a 1 there. And I am going to divide this by x squared. Done and done. I think the calculus part of mathematics, it's becoming your favorite at this moment, because this is actually pretty fun, and you will see when you work with this in class, this can be used for a lot of interesting applications, and you will have all the skills you need already. All right, let's do a few more examples together, and then you will be on your own with the assignment. So notice this one, I have square root of t plus secant of t, and I want to find the derivative of this. So derivative of square root of t, I can write this in a different way. I see it a little bit better. Some of you are very fast with this, and you magically see it without writing it down. Well, you know, I'm getting old, so for me, I will write this down. So 1/2 goes up in front, and then I have t to the power of -1/2, plus, this is not multiplication, so I just find the derivative of this and then derivative of this. Secant, I am looking at my formula paper, and the derivative of secant is equivalent to secant of t times tangent of t. And there's not, well, we can get rid of the negative exponent, so we can write this in a little bit different way. 1/2. This is going to be on the bottom of the fraction, so square root of t plus secant of t times tangent of t. Are we done? Well, I would want to say we are done, but we should rationalize the denominator. So square root of t over 2t plus secant of t tangent of t. And now this is a little bit more proper way of writing our answer, so now we can say we are done. All right, 2 more examples for us to do together. I have 1 over s minus 10 cosecant of s, and well, the same idea. I see this a little bit better if I write this as s to the negative 1 power minus 10 cosecant of s. Now I am able to find the derivative. So negative 1 will go in front, and s is going to be raised to the power of negative 2 because we are lowering our exponent. And then notice this is multiplication. Does this really matter? This is just a number. So this is going to give me minus 10, and cosecant is negative cosecant of x cotangent of x. And again, we do need to clean this up. I have negative, I have negative exponent. So I am going to write this as negative 1 over s squared plus, as I have 2 negative signs, 10 cosecant of x cotangent of x, and that's it. All right, we have 1 more example to do together, and then you will get some to practice. By the way, you did very well with the chain rule, and I did not correct the assignment from yesterday yet. I always wait for the following day so I get more of them completed. This one we have to use the product rule as we have a multiplication with the variable. So this is going to give me the derivative of the first term is 1, and then I'm not going to change the cotangent, plus derivative of cotangent is negative cosecant squared of x, and I am going to multiply it by x. Maybe we'll clean it up a little bit. Cotangent of x minus x cosecant squared of x. And we are back in trigonometry, and we are using that. We are using the formulas to figure out what is the derivative of the trigonometric function. So now that will open another door for you guys. Anyway, please make sure you complete the notes. Please make sure you complete the practice, and make sure you have fun with that.